All right. Well, welcome everyone. Thanks for coming for our second session of our road to certification for the Associate Cloud Engineer. Like I did, well, for those who were there last time, like I can't stop using the freaking thing that does like jingles in Gemini. So I took what we did in the past session and I fed it, and it's not, it's changing those slides, so that's not gonna work. If I have to go there, it's gonna work. Maybe not. Okay. So I just wasted gallons of water to make this. uh, but yeah, but the idea anyway was just to just like having fun with what's out there, what's new. So basically, this is like the idea of the agenda today. We're gonna go through small intros, then we'll kick kind of we wanted kind of level set. Because last time there was a lot of people asking a lot of questions, so we wanted to make sure everything was okay. So we could just kind of take a step back to maybe clarify some concept, and then step back in after the food on the no, actually, yeah, there's going to be a first segment with Arunesh, food break. Then we'll continue. Then Florian will wrap up, and then we'll be ready for the next session. It's going to be actually next Tuesday, so session number 3. But before we start, just want to meet your organizers. There's more and more people, which is great. So myself, Stacy Verono. So there's Florian somewhere. Caesar, who couldn't make it today. Arunesh is going to present. And we have a new addition. So Raphael from the Cirque du Soleil is actually joining us. So she's a data team lead over there. So she'll join us for the next session. Bringing that data expertise, and we'll be able to do like more like BigQuery, Vertex, a bunch of stuff with her as demos, which is pretty cool. So great addition to the team. Super happy to have her join us. So again, one big thank you to our partners. Davidson's always like it's our HQ. So thanks for hosting us. Google Cloud. Well, there's content, but also like the food has been sponsored by Google, which is great. And also, like I've put those digital because everything I do for community, I'm able to do it during my work time. So they sponsor my time so I can do other stuff past 5 p.m. So always good. So also, like through this age journey, there was all the other GDG on campus. Maybe some of you went to the event earlier this week. Was quite something, like 900 something RSVPs at McGill. And like, well, at least 500, 600 actually being there. It was something. So Build with AI following by the gala, so it was really cool. So really, super happy to be able to collaborate with our on-campus chapters. So McGill, Concordia, and Polytechnic, who just started. So if you take pictures during the event, if you want to upload them to our album, always welcome. So that way people can have a little souvenir of what happened. Come on, clicker. So we have a Discord server. For those who didn't join or were not there for session number 1, this will bring you to the GDG Montreal Discord server. And on that Discord server, there's going to be a Associate Cloud Engineer 2026 cohort channel, which is going to be the next QR code. Last week, I just went straight to it, and you need to get the invite first, so you have to start there. And also that Discord channel is where, if you have any questions, or if you want to share content, we'll do it straight there, so that way everybody can get it. Make sure, gentleman in the back, got it. And this is like, if you actually want to go straight to the AHGDG Cloud Montreal, it's kind of long, the QR code is there. But once you get the invite, you'll see it listed. Really not a problem, so you can join at that place. For those who missed the first session, the workbook, which is basically kind of the follow along of the session we're doing, also has all the links to the labs you can do in Google Skills. So the links are in there. It's a Google slide, so you can use it. Just go there. It's your guide to set up your everything you need to prep yourself towards your road to certification. Well, just our code of conduct. So just give you time to read it. So of course, if there's anything that happens, make you feel uncomfortable, come join one of the organizers, and we'll take care of it. We'll figure it out. And yeah, so we're kicking off, but like technically tomorrow is spring, right? So I just asked like Google Slide to springify my slide. Looks like this. So there's a bunny somewhere probably, I don't know. So technically spring is tomorrow. Doesn't look like it, but yeah, maybe it's gonna encourage the sun to come back. I don't know. So yeah, so well, again, like we have, for those who weren't there for the first session, like this is basically what we're covering, is the Associate Cloud Engineer. We have multiple sessions. So this one, March 19, we have 24, April 2nd, 7th, and 16, which is our last one. We're still working on the vouchers. The idea is to be able to actually have a raffle and give away certification vouchers, which is basically get you able to get the certification for $0, which is always nice. So looking into this, but also we'll have other stuff to give away. Probably like a trifecta of books on Google Cloud for developers, a bit of GitHub in there. So we'll have that by the end. So for those who missed the first session, whenever you want. All right. So kind of TLDR of everything in one slide. We're not. So basically, like it's just a journey. So basically, well, what we've covered, what is cloud? We'll cover that also like later. But going from like a capex to an opex model, for those who are not aware, like what capex is opex, is capital expenditure, which is something that costs you. My car, my house is costing me X, so I have to pay it over like X amount of years. OPEX, which is operational expense, which is basically where you pay for the resources you need. So if I consume for X, I'm going to pay for X. If I consume like X times 2, I pay twice. If I don't do anything, I don't pay. So that's the switch. So usually you have to forecast a budget and everything. When you go in a OPEX model, you'll have a budget, but it's variable. It can go down, can go up. So that's where all of this together makes for best practices when you put your cloud together. So cloud is elastic, so it's not like servers we racked in the past. It's actually, if I need resources, I spin it. If I need more, it can scale up, can scale down, and the elasticity goes to storage and compute. We've talked about the entire resource hierarchy, so how you actually set up your organization. So your org, see it like mycompany.com, and then under that you can have folders that can represent maybe business units or department within the company, and all the people under it. So people from sales don't go mess up stuff in marketing, and vice versa. You're able to get control. Control is done through IAM, and who can do what where. So like sales cannot like delete stuff in the marketing folder. That's an IAM permission. So basically, that's what it is. If you go to other cloud providers and Google Cloud and IAM, it's a concept. It's the same everywhere. Also, we always grant least privileges. That's best practices. So we don't want to say, hey, you're going to be project owner. I only need to create a bucket. Project owner means I can nuke everything. So no, my access needs to fit what I need to do. So we grant least privileges. So it's also super important to know, like when you create resources within GCP, there are things that you can change, there are things that you cannot change. And you create a project has a name can change, but a project has an ID, which is that unique ID that will never change. So, because that's basically your link to all the billing and everything, so that's that key value pair with the project ID that cannot be changed. That's something that's important to keep in mind. We also saw that we're able to access Google Cloud through the interface. We went to the web UI in dark mode. And also, we had the Cloud Shell. We also have the CLI. If you install the SDK, you're able to do that straight from your laptop. You authenticate, then you do your things. The thing we didn't really dive into by the end, but it's super important, is the billing part. There's also observability. We'll cover that later. But like the billing part is like, well, I'm spinning resources on demand. Like somebody needs to pay for that. So there needs to be a credit card attached somewhere. So that's where billing comes into play. A billing ID, you can see it as a credit card. So you can share it with maybe the marketing team, but the sales team cannot access that card. They can access another card or another billing ID. So you're able to segregate consumption based on access also. Observability, think about that. We're not going to go deep there, but just like think about like monitoring, like what's going on inside my environment. Is my project up? Am I hitting quotas? Like I'm not supposed to attach 20 GPUs in my project because it's expensive. So there are alerts and everything, but all of those signals can be brought somewhere, and that fits within the observability stack, which we'll go more in depth later. Just wanted to TLDR it. And the last one, which is, well, follow the study plan, which is what we're doing. We're at the second session, and you go through your skills. I'll cover that a bit later. Just, was that like 2 hours ago? When so I've always, well, I did the music stuff, but like a few hours ago there was something that dropped from I think it was on X from Google Cloud directly saying, hey, by the way, no, Notebook LM, like the thing that people that paid $300 a month to do is now available for pro subscription. So if you use Notebook LM, if you ever used it, like probably most people know about it. If you go to Notebook LM, you're able to get like video overviews that brings you like explainer and brief, which is you feed a PDF, it's giving you like a slide with video. It's great. And if you put it in Google Drive long enough, the subtitles are gonna be put by themselves. Not so long ago, the cinematic format was released for the Ultra subscription. That's people who pay $300 a month for Gemini, so and everything else. But the cinematic view takes the same format, but actually makes the slide inside the slide move like you're watching a movie, which is kind of crazy. So what I did, it's gonna kind of go through a recap of what I just did, but I take the same. It's called ACE1 Recap. That's my notebook. It has the slide deck and everything that we've used in the first session. I did a bunch of stuff already with it. I've shared it. But I say, hey, you know what? Let's actually like spin cinematic just to see. It took a while. Like it took a good 10 minutes easily. But then it started. Is there?
Staying competitive in this environment now requires a specific set of operational skills. The Associate Cloud Engineer certification serves as the.
So it created like a 5-minute video of a recap of all the material that I did, but it created stuff that's not even there. It created stuff. It created the subtitles. I took the video, I put it in Google Vids to generate the subtitles automatically, and I exported it back, and I just like drop it so we can present it. But it's actually taking the material and making and I give it the styles that give me like a steampunk kind of vibe. So we have that industrial kind of feel that goes with it, but it takes the material and gives you that cinematic, and hopefully that's not a real Google Cloud data center. So, but it shows you everything and it adds stuff to it. It highlights specific things, so it's pretty cool. We're not going to go through everything, but I just wanted to intro like this. This is like right now. It just happened, so I really wanted to share it. So if you're good on like learning on the bus, learning on Notebook LM is a great tool. You can get your podcast recap. You can do a bunch of stuff. So just wanted to highlight this. It's always I think it's always great that but it's always also impressive that you feed material and they're able to like represent it, not just like static, but with movement. Quite something. So yeah, just wanted to call that out. Most of you, well, everybody actually like RSVP, got an email for Google Skills. So with the workbook, there are links to training materials or labs that you can do that go way in depth, that actually spin the Google Cloud environment also, so you can, and everything is like free of charge, so make sure you go there. It goes along with the workbook. This is where you can actually go hands-on and test it out straight in Google Skills. Also, for those who Florian did the check-in, we're also gonna start like giving out, we have also Google Cloud credits. We've mentioned that if you've never been to Google Cloud, you create your account the first time. you have like that $300 credit that goes. You have free tiers also, like where low resources you use, it's free, so you can play along. But this gives you like it's not much, but sometimes you want to test stuff out. You'll have like a small, see it like another like a gift card basically that's brought into your GCP console, and you can start consuming against it. So as we get more and more like actually check in, we'll give those out away. That's going to be in another email with how to activate it. But the thing that everybody got is the credits, because we finally got the email. And if I'm not mistaken, Mr. Clicker. All right, it's finicky. So I think so I'll pass it along to my friend. You click and it goes that way. You click on the other arrow, it goes the other way.
Thanks, Daisy.
Oh yeah, yeah. Give you the mic. There you go. Wow. Yeah, it's all yours, man.
Thanks, Stacy. Hello, guys. Quick introduction. My name is Benjamin. I'm working since 15 years as a Linux system administrator, and since 10 years I'm working especially as a cloud architect for a big retailer, and I'm focused on GCP. So I'm a cloud architect. I love Linux. I love open source. I love Kubernetes, and I'm not a developer. I'm not used to. So, just a quick reminder, I have 20 minutes to present you the base of the foundation of the cloud infrastructure dedicated within GCP. So, when I started IT, there were no public cloud for sure. We were working on physical colocation, so on-premise data center. We are in the famous CapEx FinOps model, so we are buying servers, we are putting those servers inside the rack, we are managing the storage, the servers for sure, the operating system, the middleware inside these servers, we are handling the network, the memory, we are handling everything inside those physical data center. After that, we just discovered the virtualization. It seems weird, but it's not. It was pretty cool 15 years ago. So basically, it was not especially a physical hardware. It was we have the capabilities inside one physical server to deploy a bunch of virtual machines. It was totally crazy for us. And after that, we have the cloud computing, who is offering us fully automated services that we are naming serverless. We are not taking care in charge the underlying infrastructure. We are just asking some resources, and this is magic. So basically, when we were working on premise, we have all the responsibilities dedicated to our teams, the hardware, the storage, network. All the responsibilities here are represented. After that, we are talking about IaaS, infrastructure as service. So basically, this is the virtualization section. We are talking about the platform as service, and we are talking about managed service. We call it SaaS, software as a service. So Gmail is a SaaS, Twitter is a SaaS. Every application that we are using is a software as a service. So basically, on-premise, we are handling each part of the security and the responsibility models of the infrastructure resources. And the more you are using the managed service, less you are managing the underlying infrastructure. And Google is providing us IaaS, PaaS, and SaaS services. One major advantage to use the Google Cloud Platform is the global network infrastructure. They are pretty good to do some networks. They are using a bunch of cables around the world. They have data center all around the world. They are putting a lot of money to develop their own data center, their own technology. They are building their own chipset, their own TPU. and they own a bunch of data centers all around the world. So there's a lot of investment in terms of networking and in terms of infrastructure and data center. So basically the cloud is the same way that we were using IT before the cloud. It's still data center with hardware, but Google is taking in charge the responsibility of maintaining the hardware, putting the new storage, new disk, and stuff like that.
So as I said, we're not seeing, but we also have a region in Toronto in Canada, so we have.
Yeah. True.
So we're Montreal, we don't want to see Toronto.
Yeah. And for information, Montreal was the first data center inside GCP who is totally green. We are talking about sustainability a lot, green IT a lot, and I think you know that in Quebec, in Montreal, especially with Hydro-Québec and the... Yes?
I read somewhere on Google Cloud documents that they have these locations, but there's also more locations for their CDN service.
Yes, true. Those little dots are data center finally, so we are using those data center for deploying the resource that we are using inside GCP. And we can see here around the fiber and the optical networking part, we don't see it actually on this map, but there is a lot of point of presence. We are calling that POP. And finally, this is edge server. They are not the property of Google. They are renting some data center to put their hardware. And those point of presence make that if a user is near Sao Paulo, but here, for example, and not in Sao Paulo, within reaching a Google services, for example, is passing through this point of presence before reaching the actual Google data center, where the resource and the service are located. So yes, true. We are calling that POP, point of presence. And this is edge, we are calling that edge services to just make the answer the more quick because of the to be able to respond very quick for the end user. One stuff who is really important inside GCP, and this is the same for AWS, not especially the same for Azure because of Microsoft and Windows, but Google is using a lot of services that are managed, for example, Cloud Bigtable and Dataproc, who are based on OSS, open source software, especially the Apache Foundation. Maybe you already know the Apache Foundation. But for example, Dataproc is based on Apache Hadoop. So this is a data solution to ingest and transform a massive data, unstructured data, on multiple clusters. And Cloud Bigtable is on Apache HBase. So this is a columnar databasing. Google is using it, for example, to store the data and all the metadata for YouTube and all those services that they are developing. For those that are using Python, TensorFlow is a very common solution to handle Python development for machine learning and stuff like that. Kubernetes is a solution that is open source and was created by Google at the beginning. And Google Cloud Infrastructure is running on a big cluster of Kubernetes. The name is Borg. This is not the same as Kubernetes, but they release a part of their infrastructure, Borg, with an open solution, and this solution is Kubernetes. I think you already, maybe you already not using Kubernetes, but you just heard about Kubernetes. Forseti Security is not used anymore inside GCP, but it's an open source solution for security. And this slide is representing the operation solution that is present inside GCP, with based on stack driver with also the operation and monitoring solution that was used in AWS. So yes, GCP is using a ton of solutions who are based on open source. And that's pretty cool because if you want to go inside GCP and you are already using open source solution, the migration is pretty straightforward. If you want to leave GCP, you can leave and you are not a vendor lock-in. So GCP is providing a ton of solutions. They are cost effective because we are using the pay-per-use model. For example, we can use some Jedi mind tricks to make it more efficient in terms of FinOps. We are using a lot of FinOps strategy to maintain the cost the lower as we can inside the Google Cloud Platform and each cloud provider. Highly scalable, as Stacy already told us about the scalability, the elasticity, and stuff like that. We can, Arunesh told us 2 weeks ago, but we can create some custom machine, so virtual machine with different type of vCPU and RAM. There are a bunch of solutions around the IoT. They are working with a lot of API. Each services inside GCP is an API. I think you know that, but Google is really good to make some analytics and big data. This is a data company. They are very good for the AI, for sure. And they provide us a bunch of services who are serverless. So basically, you are writing your code, you deploy your code directly. You don't manage the underlying infrastructure. You can access GCP with a bunch of stuff, the web console, the Cloud Shell. We already saw that last week. There are a bunch of tools that we can use to manage our infrastructure. We can deploy the infrastructure with Terraform, for example. There is a little mobile app to just receive your bill and your alert when your service is crashing. And yes, you have a CLI to manage your resources with the famous SDK. So we were talking about data center and the location that we can use inside GCP. So GCP has a bunch of data centers around the world, and we are talking about region, and each region have multiple zones. And finally, each zone inside a region is a data center. A zone is a data center. So if you are using an application and you are deploying your resource across 3 zones, you are using 3 different data centers. So this is pretty cool because this is a solid construction in terms of high availability if you are using one single region. And if you are using a bunch of regions, your application is more available. So there are some services that are zonals. For example, Compute Engine is inside the zone. You are choosing the region and you are choosing the zone when you want to deploy your machine. And some services are multi-regional or regional. For example, Cloud Run with the container as a serverless solution inside GCP. You choose the region, you don't choose the zone. And for example, BigQuery, you can choose a multi-region location, so US or Europe. And when you are putting the data inside a multi-region, your data is replicated inside a bunch of regions inside the Europe. So for example, I'm working with a French company. We need to put the data inside the European Union. So we are using only the Europe location. And if we want to have a better high availability, we are using multi-region, especially for the data, like a BigQuery, for example. Some example of different regions. So basically, the standard for each region, minimum 3 zones. US Central is a particular region inside GCP. I think it was the first region created by Google. Definitely, this is the one that GCP is using by default when you are popping a resource, because they have 4 data center inside, 4 zones and 4 data center inside this region. Don't tell me why this is not a D region. I have those questions one time. I don't know why. But yes, US Central is pretty cool because it costs less, finally. And if you are doing the...
Commission hardware, they commission the zones also.
Oh,
And like usually the I, well the I, it's not a number, but like A, B, C, D, E, F, G. We don't really see like G, but if G were to pop up in US Central, that's where the latest hardware is sitting. The new stuff.
yeah.
The letter. It's probably gonna cost more. It's gonna be more expensive, but if you want to test like maybe the latest Intel CPU that they have or whatever.
And I know for sure that US Central is the first region who are deployed the new services and new features inside GCP. So basically, when they are rolling new features, the first data center where you can use those features is inside US Central. So the new version of Gemini or whatever, you can use first on the US Central. And yes, Western Europe is so much later, for example.
When the commission assume the migration is done like automatically by Google, or
Yeah, no, it's fully transparent. You never see what's happening. So either they're gonna, because they move it out because I don't know, they want to redo the fabric for the network or something. So instead of they really just like vacate everything. So it's something that's super rare. Like that we haven't seen this like in years. So now they're more adding. We don't really see adding more stuff. Like they usually stick to tree and like the so and now they start like spreading the hardware a bit everywhere. But at the beginning, the inception of GCP as it grew as a full cloud platform, we saw those like decommissioning.
Oh, okay.
Like, hey, there's no A at one, and then the other one's like, yeah, we're missing the, I don't know where, it went somewhere. So, but yeah, so it's usually linked to hardware decommissioning.
Okay.
But it's super rare right now. They're just like they have always.
I don't see that
refreshing,
from my
so
entire life, yes.
it's
Good to know.
yeah, working for the operation team that makes that that's their daily job. It would be interesting to follow those guys.
So just a quick recap, a ton of regions, 43 zones, the famous network edge location that we were talking about. And yes, there are the investment are massive in terms of data center, TPU especially those days, and subsea fiber. So, and
Google does the RAN network, the RAN cloud provider that actually owns from the silicon chip inside the board to the fiber that brings you to their cloud.
yeah. Okay, just a quick. Okay, a quick note about networking. When we are working inside, when you are inside GCP and you are working inside your organization project, you can create a VPC, virtual private cloud. Basically, a VPC is a space where you can deploy some network resource to handle the fact that your resources are communicating each other privately. So inside the project, you can deploy a VPC. A VPC is global. And inside the VPC, you can deploy some subnet, and subnet are regional. They are spanning the zones. So basically, you can think about deploying a VM inside this region, and the VM are using the same subnet inside each zone of this region. This is pretty cool, actually, because Azure and AWS is not working like that. And for people that are managing network at scale, it's pretty cool to have those kind of functionalities, because AWS each time you need to deploy some resource inside a VPC, you need inside your network, private network, you need to create another VPC. So VPC is global is a really a great feature that Google is implementing inside their solutions.
So when you say global, like if I have a project, it's per project or per
It's what? Sorry?
the VPC
Yeah.
under project?
Yeah, a VPC is inside a project. By default, when you're creating a GCP project, you have a VPC, and the name of this VPC is default. And it's inside this VPC, you have one subnet inside each region that GCP is providing you. So a project is VPC is inside a project, and inside the VPC you can deploy subnets that are regional. And yes, each project can have a VPC and multiple VPC too. And that's a good question because we can peer the VPC. Imagining that I'm working with Stacy. We have we have our own company and our own organization, GCP organization. And today I deploy a new application and I want Stacy and the people inside this GCP organization to reach my application privately. We can think about doing a VPC peering to just peer the two VPC and make a big one VPC to just be able to reach privately each other our own resources. So peering is pretty cool, and it was the first solution provided inside GCP to just make intra-VPC communication, inter-VPC communication. One interesting and crucial stuff, we don't need to overlap. So we don't, to make a peering, all the subnet inside my VPC needs to not overlap the subnet inside the Stacy VPC subnet. Sorry. That's okay for that? Wow.
You're gonna have to talk unless you're on Dropbox.
It's not working anymore. Okay, another solution with really used inside big company is a solution that is provided at the VPC level, and we are calling that shared VPC. So basically inside GCP, we can think about having one GCP project to handle all the VPC and the network resources, because it's tricky to handle networking resources. We are talking about security, interconnection, routing, stuff like that. So we need some skills, and in a big company, generally, we have dedicated network teams that are handling inside a single project all the resources related to the network. And finally, we are providing some projects for the developers to be able to just consume the resource inside this project. So this concept is pretty cool because we are centralizing all the administration of the networking inside a dedicated project, and each team can just deploy their VM and their resources and use the resources, the network resources from this project. So this is cool because we have segregation of duties. Networking team are handling their network resources, and developer teams are just developing application. They don't need to know about firewall rules, routers, interconnection, VPC peering, or stuff like that. They don't want to handle those kind of stuff. And this is cool because, yes, centralization of resources mutualization. We don't have to multiply the number of VPC inside each project. So this is a really cool solution. And every big company who's working inside GCP is using shared VPC.
As we mentioned, least privileges, access, in the recap. So like, and also like who can do what where. So if I want, if I need a network, my permission is like I'm just a network user. But if I'm a network admin, I can do stuff, but I don't want the entire thing to manage a network. No, it's dedicated. There's a task. It's within our own project. The networking team play in that box. They handle all the connections.
Exactly.
And then you just, hey, I need that network. I gave you access to this network, not the other one. So you're able to connect, and then you're able to do your stuff. But then you have like that massive hub that basically is like your big network central, where the networking plays. Because you can have VPNs there, you can have like
Exactly.
which will go later in it, but they can manage all of this stuff here, where you really, as a user, I just don't care. Like, just give me a network.
Yeah.
Just for visibility point of view, in service project, I can see the VPC or I cannot see?
You can see the resources that are EM granted to you. You can see the VPC, but you have in the web console, you can go to shared VPC and see the subnets that are shared with your project to be just consumed by your compute engine, for example.
Okay, so I will just see my subnet.
You just see the subnet that you can consume.
So if you have 20 networks on the left, like on the like where we're out, and then you're in your project and you have access to 1 or 3 networks, you'll see just.
I can show you that at the break.
You'll just see the stuff you're supposed to.
Because even if in my sandbox I'm using a NOS project with dedicated to all my network resources, and when I'm deploying some resources, it's inside the service project.
I'm just asking not about security. Like if I use Terraform to deploy compute engine, so
Yeah.
I need to mention the VPC name or like
Mm.
and the subnet ID, stuff like that. I will be able to see it from my project. That's my question.
The question is good, and you just need the right permission to use it, and you deploy it with Terraform. Yes, and inside the web console, you can just see the subnet that are shared with you.
Another question.
Yeah.
Yeah, I just have a question. All resources on GCP are capable, are compatible with shared VPC, or there's some resources that you need to set up a hub spoke?
That's a good question. Each resource that are using IP and network are compatible with shared VPC. It was not the case 5 years ago, but now this is the case. So basically, we are talking about compute engine. We are talking about Cloud SQL, so PostgreSQL instances, MySQL and SQL Server. We are talking about Apache Airflow with a package inside the solution with a Composer, for example, Kubernetes and GKE for sure, that are using those kind of networking resources. Even for serverless, we are not managing this infrastructure. So Cloud Run, Cloud Function, for example, we can use a component inside a VPC. This is not a subnet. We are calling that a VPC access connector to just put it inside our Cloud Run and serverless services to be able to reach privately other resources inside our VPC. So even serverless solution can use some network resources inside the shared VPC to be able to just communicate privately. It's a big concern for security guys or admin and network administrator. First, remember the beginning of AWS. I think each billing account, I can't remember the name inside AWS, but each project was shared in terms of networking. I was able to ping your VM to, if you put admin inside your MongoDB, I can reach your MongoDB, stuff like that. It was totally crazy. So it was not possible for major company to go inside the cloud when it was the case. And this is not the case anymore. Just a quick slide about exposing our application. We are developing we are deploying private resources, but for sure, sometimes we need to be exposed publicly our website, for example. So we can use a bunch of solutions. Cloud CDN is a content delivery network to just inside those famous point of presence to be able to store your static files the more inside those locations to just avoid the fact that we are downloading each time the PNG, the JS, stuff like that. I think you are like a Cloudflare solution inside GCP. There are services to be able to load balance your resources. It can be a cloud storage, for example, if you have a static website, you don't need a compute engine or Cloud Run or stuff like that. You can put all your JavaScript and static file inside a bucket and just expose it publicly just behind the load balancer. You can put GCP and Google Compute Engine, Google Kubernetes services, whatever the kind of services you can expose via this pattern. And for sure, you can also expose via an internal load balancer inside your VPC with a private address if needed. Quick reminder about the storage and the database solution that GCP is providing. So cloud storage, the bucket to store some files. Cloud SQL, this is a managed services for relational databases, so PostgreSQL, MySQL, and Microsoft SQL Server. There is another solution, the name is AlloyDB, based on PostgreSQL, which is pretty cool to use if you are doing some GenAI, because AlloyDB is capable to handle the vectorization of the data chunk, for example. Cloud Spanner, with a massive and global relational database, generally used for very big company like bank and assurance. Firestore, I think you already know Firebase. This is a backend NoSQL solution inside Firebase. So Firestore is a NoSQL database. Cloud Bigtable, based on Apache Base, is a non-relational database, columnar database with a massive throughput. It's very used for in IoT, for example, bank, assurance, to store some logs, massive logs. And BigQuery is the data warehousing solution that GCP is providing. Each company is using BigQuery because each company have a website. Each website have Google Analytics. And behind Google Analytics, inside Google Analytics, you can just click one button to export all your data inside BigQuery. And inside BigQuery, you can just connect what kind of dashboard solution and BI solution to have some insight about your traffic and your website. BigQuery is very used inside GCP. We have also in-memory solution. I think you already know Redis, for example, maybe. Okay, so Cloud Memory Store is the managed service for Redis. So this is good to a good solution to store user session, for example. Relational, we are just talking about Cloud SQL. Nothing special on this slide. We were talking at the beginning about the different kind of solution and infrastructure selection that we can use inside GCP. So we have the infrastructure as service, compute engine, virtualization. We create some virtual machine. We are deploying Debian, Ubuntu. We need to patch them, upgrade them, install the middleware inside the patati patata. This is not totally managed by the provider. You are handling all the section inside your VM. Google Kubernetes Engine, so everyone is talking about GKE and Kubernetes since 5 years. This is magic. So it's not as magic as everybody is talking about. Behind Google Kubernetes Engine, there are some compute engines. So GKE, this is the Kubernetes managed solution. Kubernetes is a container orchestration service to just deploy some container at scale inside GCP. App Engine was the first PaaS services GCP was providing at the beginning of the platform. So you are developing your code, you bundle a zip, you put it inside App Engine, you have your URL, traffic goes up, you have more instance, pay as you go. No one is using App Engine right now. This is forbidden. They have a bunch of services like Cloud Function and Cloud Run who are doing the same stuff. And it's not a joke. App Engine is still available inside GCP. But when you are going to the console inside App Engine, they are telling you that you need to use Cloud Run. So I think they are still using App Engine because I think it's no, it's not TikTok. Snapchat is already running on App Engine. And if they are not decommissioning App Engine, that's because Snapchat is using App Engine. Cloud Function, it's pretty cool. Same stuff. You deploy your code. And this is a programmatic execution of your code based on an event. So you are receiving a message on a pub subtopic, for example. There is a new file inside a bucket. There is a log appearing inside your GCP project. We can think about every kind of event. Your function is executed at when this event is happening. So this is really cool. We can think about a bunch of use cases. Send an email, generate a PDF, stuff like that. Microservices, event-based, really cool. And after that, they have a bunch of managed service, for example, Vertex AI. I think you already heard about this service, a bunch of managed service that you can use out of the box. You don't see the underlying infrastructure, ready to go. And that's pretty cool. They have a good portfolio of services. Cool. Sorry, guys. It was a little bit. Thank you.
Can you hear me? Yes. Good? Okay. Great. Okay, so I see some familiar faces here. I just want to ask, is there anybody here who is really looking for getting the certified after this session? Perfect. And also you guys, are you new to cloud? You have already basic knowledge of the cloud, of the networks? Good, great. Okay, so first of all, my name is Arunesh. I have worked in as a system administrator for like 5 or 6 years. So I have a background and I did 5 certification like in last 3 months. So this session with the associate cloud engineer, I just want to make sure, I know you guys have some basic knowledge, but what this certification is about, it's like a triage. So angry customer is calling, their system, it's a support company, like I worked as a system administrator, so I'm going to take that example. So somebody's PC is not working, they call a company, triage is picking up the call. They need to know where to forward this call. So Ben, he has 15 years of experience. He cannot take that call. He is so expensive, right? That call needs to come to me, right? Or somebody else who is that level. So to my understanding, cloud engineer certification is like that. So he talk about Cloud Run. talk about BigQuery, we don't need to configure anything in this certification. We just need to know how they work, what is happening underneath, which services, with this service, which service is going to be beneficial, that kind of stuff, right. So, it is just to make a foundation. So, if I show you something really quickly, let us go to GCP compute documentation. So, this is compute engine documentation. Okay, so this is all compute engine, right? How much you can learn. So, this is a lot, and not everything you need for the exam purposes. I am just talking about this cloud, associate cloud engineer. It's like just knowing the services, how they work, and how we can implement. So, let us go back to the triage example. So, if there is something, there is a new user adding to a company, and they say we got this user, this is the first name, last name, this email we want, add this user to the Active Directory, that triage can do it. They are expert, they are technicians, but they know some of the stuff, they know where they can route, and they know how everything works, right. So, similar thing we are going to do in this certification as well. So, when I am going to explain all these services, like we will talk about App Engine and Cloud Run. So, there is one example. So, there is one company, there is a question, it says, you know what, when there is no traffic at all, my company does not want to pay anything. Which service you will use, App Engine or Cloud Run? Cloud Run is 0 down. So, there is no traffic, they are not going to charge you, right. So, that is it. You do not need to install App Engine, you did not need to know how to implement Cloud Run, like really in a deep networking, VPC, is all that. It is all they are going to test you on the understanding how these all services, GCP services are interconnected, and the question is going to be based on those things. Okay. So, I am going to take my slides to this. Here you go. Perfect. Okay. So, planning, configuration, how we can configure compute engine, how we can configure networks, how we can configure cloud on all the services. So, before that, I remember when Ben said years ago everything was on premise. I worked on the premise, I never worked on, when I started I worked on premise. On premise means I have this computer, suppose this is a server, everything is connected here. So, the internet goes down here, I am no longer connected to internet outside the world. So, that is a disadvantage of from on premise, and on top of that you need to spend capex, you have to spend money on upfront, you have to hire a senior engineer to manage your stuff. It's a lot expensive, but for the cloud what we can do, we can just pay for what we use, nothing else. Let us go with that. So, agenda, cloud service models, infrastructure as a service and platform as a service. Then we are going to talk about data storage. So, little bit about the data storage. So, that is one of the fundamental things they are going to test you in the examination as well. So, you have a website, and there are some transactions going on. Would you use cloud storage or would you use a database, some type of database to have all those data stored somewhere? Definitely you will use a database because these are all transactional data. They will have timestamp, they will have client name and IDs and all the raw columns, or maybe in the JSON format if it's a NoSQL thing. So, we need to understand what are these services are, what company wants, and then we direct them to the right solution. Comparing GCP storage, again we are going to do that, and storage classes. Yes, I have 4 terabyte of hard drive. It's sitting in my closet. I never touched it last maybe 3 or 4 months. I'm not paying for anything, it's just sitting there. Same thing with these storage classes in Google. So, you have pictures from your childhood pictures that you haven't touched for like years. You should not be paying for those. You should not be paying heavily for those ones. But for the other transactional data that we are using on daily basis, Google charge you for that. But for the, so these are the classes. So, we can put a bucket into a different class. There are different classes, and for different class they have different pricing, and that is for beneficial for 30 days, for 90 days, for a year, and if suppose it is a backup. So, as I said, I was a system administrator. We used to have companies backup data or backing up their data. So, they have like 100 gig, 200 gigs of data, but then it is like if we have in GCP, it is going to be a lot costly. So, they put it in a different class where they say, okay, once in a year you can touch it, you can access it only once in a year, then it is a lot cheaper. But the other data that you are using on daily basis, so it's you have to put in a different storage class. Okay. So, we had servers, routers, switches, everything on premise, and we are expert on that. We are building servers, we are connecting those. What is equivalent to that? That is infrastructure as a service. For infrastructure as a service for Google, what they are doing, they give you server, bare metal server. It's like that you bought something, you have the server, it's there, but it's your responsibility to configure it. You patch the OS. First of all, you choose the OS, which OS you want. You want Windows, you want Linux or any other. You have to choose it. Who is going to patch it? So, that is the customer who is going to patch it. Who is going to configure the network? Yes, everything. So, basically it is like a bare metal server, ship it to you, you configure it. So, that is the infrastructure as a service. So, that is going to be one of the critical questions they are going to test you on. 3 or maybe 3, there are more actually the models, but these are the main ones that we need to understand. For infrastructure, they say the company is looking for, they have highly skilled system administrators, they want a full control over GCP services, the servers. So, which service they are going to use, SaaS, platform or infrastructure, that is going to be infrastructure as a service. But then there is a more responsibility. I think in the other slideshow, oh not this one, but this one, we had, yes, let us talk about this one. Compute engine, infrastructure as a service. So, what it says, towards managed infrastructures, we have to have a senior developers or administrators who is going to manage these ones. The more you go to this side, it's like, okay, anybody can use this one. But this one you need specialized system administrators, Linux and administrators who can configure compute engine, Kubernetes, like that. And then we have platform as a service. So, platform as a service. So, Google Cloud Run is a platform as a service. So, they give you the platform, you bring in your repository, you bring in your application, you deploy it there. What is the benefit? Like, why I cannot do that in infrastructure? What is the benefit? The benefit is I don't need to take care of the operating system. If something goes wrong with the operating system, Google is going to take care of that. There is a bug, they want to do up patches, Google is going to take care of that. So, and infrastructure as a service is expensive. Yeah, expensive. We are not going to talk about, because it depends on your use case, how you use these services. Platform as a service, they give you everything, they give you most of the stuff. You have your application, you run it, and then you have a running website. Software as a service, you use Gmail. In Gmail, you are doing nothing. You just log in, check your emails are coming through, we are sending, forwarding. If there is any issue, Google is taking care of. We don't have any concern, like we are not even paying for those things, right? So, that is the model. And then there is a function as a service. I think there was a slide where we had the function as a service. So, we can run. So, basically, suppose I have a bucket. Bucket is a storage where I can store my data. In a bucket, all my logs are saving into the bucket. So, whenever there is a new file, somebody is adding a new file, I have a function. When it triggers, there is a file added to my bucket, it automatically runs it. So, basically, infrastructure of service is useless for me, because there is a person in the world somewhere, at their own time they are going to add some file. I do not need infrastructure as a service, too expensive for that. Platform as a service, I do not need it, because it is just a function. And then the software, no, I do not even need that. So, function is just, it is tracking logs, and it says, oh, there is a new file, and then it runs a function. So, now that is a lot easier to just run one function. So, let us talk about infrastructure as a service a little bit more deep, and I am going to show you in a console as well how we can configure a compute engine. So, we need to choose for what memory we need, what CPU or GPU, what we need, which one is going to be the how many persistent disk you require, is it going to be zonal or regional, and the storage, how much storage we need, right. So, let us go back to, let us go to the console and let us have a look. I think I had console somewhere. So, this is my project right now. I am in a self screen project. So, from here you can go to compute. Yes, thank you for reminding. Good. Okay, so that we can go from here to compute, or there is one compute as well. All right. I think I have only one instance. Yes. So, as Stacy mentioned the other day, so by default we get the zone or the region US Central 1, right, and this is the F1, right. Okay. So, let us create an instance. So we have center 1, then we gotta choose a region, and then we have the services. So all these things, when I was working on premise, all these things we were talking for hours, for days, for weeks. We are planning what we're gonna bring in, because that's capex. It's the money that company has to spend upfront, right? But here now I gotta choose. I can choose any. So this one is the low cost EC2, EC, sorry, that's AWS. So E2, right? So I can I can choose this is the low cost one. So I can choose this one. There is somewhere the cost as well. You can, when you change it, you're gonna see the cost. Let me see. I think it's on the, yes. Sorry, I'm just zooming out. So 25.
Take the third one.
Hmm?
Take the AMD Turin
Yeah.
with 4 terabytes of RAM and
Yes. So yeah.
$20,000 a month for VM.
Yeah, let's change a little bit. Let's see how much price is gonna. So for C4, how much is? It's not gonna be a lot, just little bit.
More
72.
expensive are the memory optimized.
Yeah. Okay. Okay.
And
So
basically, even if you go to div menu and you want to create a machine with memory optimized, especially for the Superman
mhm.
with 1 terabyte of RAM, you can create it as is on your GCP project. Generally, you have to open a case on the support to tell them, hey guys, I'm gonna use a big machine.
Yes.
Can you remove the quota on my project because I need this machine. And we are talking about machine around 3 or 4K per month,
Per month. Wow.
especially using for
And
BI and stuff like that.
if we go to memory optimized, we will not see them available to choose.
You actually on the web console you can see them. If you click on memory optimize, Arnesh,
Mhm. One second.
can you
On the top.
on the top of the table, can you click on memory optimized?
Mhm.
Yeah. Can you click on the M4 to just be able to see the price?
I don't have credits that much.
Okay, this one is 1,000.
1,000 monthly estimation.
If you select some, it's already telling you might not have quota for.
Yeah. Yeah. I think that was this one. Yeah. You might not have enough. Yeah.
Yeah.
Yeah. Right.
This is not a Minecraft server for you. Definitely not.
So from the exam perspective, they're gonna test you. So company needs just run a website. It's a small. There's not too much traffic going on. They need just a basic server or something. So which service you will use? Then we will have some options there, and we need to. Oh yeah, this one is gonna be the beneficial, right? And or maybe there's a developer who's just testing something and they need something really friendly, which is like cost friendly. We don't want to pay too much. So which service, which machine they can use. So these kind of stuff you're gonna see on the exam, and this is for $24. And tell you the truth, I use. Let's go back.
Just a quick question, Avnesh. On the exam, they are really asking you to know those kind of precision in terms of machine types. You know what I mean?
Yes,
Yeah.
in this sense, like they are, they can ask from the a company is looking a developer. Sometimes they say as a hobby developer, what services you're gonna use, what compute engine, machine type you're gonna use,
Wow.
right? So
Because even if I working within GCP from a bunch of time,
yeah,
I don't know
yes.
which machine type to
and that is the example. They are testing you. They just So Google is not going to tell you oh you pass with 99%. Oh you fail with like 20%. Like that. No, they are just going to say you pass or you fail. So what I understand, they have 4 options. For 4 options, they have some grading on based on that. So the closer you are, the closer you are going to get to this one, right? So like even if it's a question that is like suppose if you go on Reddit, you ask, everybody is concerned about in associate cloud engineer certification, do they ask for machine learning related questions? Go, you're going to see all these questions, and yes, they do ask for, but those questions are like really easy ones that you can figure out. I had a few questions related to machine learning, but they were like very easy to figure out. Like yes, this is the option. My experience is really weird for these experience with all these services. So I always had only 2 options to choose from. Normally they have 4 options. They are all equivalent, and it's very tricky to figure out. I don't know, but for me it was like just with 2 options were like apple and oranges. It doesn't even make sense to me. These are out. So I was like, in 1 hour, every single certification in 1 hour, I am done with all the questions, and next hour I'm just making sure that it's whatever I chose is the correct one. So I hope it's gonna be easy for you as well. The But don't get tricked with that, because I had some system administrator experience from like years, like 6 years I worked in that, right? So for the networking part, with how Stacy and Ben, when they were the VPC peering, they were talking about. So those questions were very easy for me because of from my experience. So it might be different for you guys. So yes, so this is a Spot instance. With Spot instance, so there are different types of instance, but I just wanted to show this one. Spot instance is like GCP says, okay, you can deploy this instance, but I can take Google. They can take these resources back anytime. They're not going to tell you. They're just going to shut it down. But they are very cheap. Good for me. I'm just a software developer who just need to test something. This is the smallest cost effective instance that we can create. So that's why I have it here.
And just for example, they are shutting down this instance whenever they want. And one usage of Cloud Function is to reach inside the log an entry who is telling you that, hey, Google is stopping and shut down my instances, to just make a Cloud Function based on this event to just restart your machine.
Yes, because you are responsible to reboot it yourself.
Exactly. When they are shutting down the Spot instance, you don't know that.
Yeah.
You wake up and, oh, my instance is not working anymore. So
Mm.
this is one example of what we can do with Cloud Function. We can really just execute a code logic based on an event, a log entry, a file on a bucket, whatever the type of event that we can imagine. Yeah?
Are you saying, sorry, that even though this instance was shut down, it's still a resource that's shown in your console?
For sure.
Yeah. So say as this one.
The machine is still on your console, inside your project, but before she was running, now she's just shut down. They are not deleting your machine and the disk attached to your machine. They are just shutting down the machine. Finally they need the resources, they need the CPU and the RAM for another customer who is not using a Spot instance, and because of their capacity planning inside their own infrastructure, they are just, okay, you can use a Spot.
Yeah.
You have a big a big price on this type of machine. I think it's 14% less
Yeah.
than a standard one. But I can shut it down when I want. That's the contract. The GCP is not deleting any data inside your project and any resources. on pay-per-use usage of the service.
Some cloud providers, even when you shut down your VM, they'll still charge you because you have that resource. So that's not the case with Google Cloud.
That's not the case.
So see, here's the thing. So when we shut down a VM, right? So it's a CPU, it's memory, everything connected. But here the storage is separate. It's a distribution distributed storage, right? It's a separate than the instance. So when instance goes down, it's like it's not consuming electricity, it's not running any CPU. They are not charging you. If you are not running, they are not charging you. But your data is there. Your data is in storage, so they're charging for the storage. And I believe it's like I tell you to like I am never like I have $5 credit from it's still sitting there, because mostly it's in the free tier where you can use most of your services. So this is a standard VM and that's a spot one. And you say VM runs until preempted, so anytime they can take it back. So the region is overloaded with a company decided to just turn on so many services or servers, and then they are running out of the resources. Google is running out of the resources. They say, okay, turn off all the spots VMs. Let's give them priority because they are the paid customers. Spot is not, right? So this is how you create what it's not available. Okay, now this is provisioning. So let's see how much we get as a cost. $12. Earlier it was $24. So kind of 50% less.
You always have a question about spot instances inside the GCP exam. Whatever the exam is, you always have a question about spot.
Always, yes.
Because you have your financial director is telling your web department that we need to lower the cost inside your GCP project. Patati patata. What can you do to just lower the price of your GCP resources?
If you have a job that actually, like, you have a job that if it stops, can pick up where it left off. Spot instance is perfect.
Yeah.
It's cheap. They kill it. It's gonna, when it starts, malfunction can pick it up. Boop, you continue your job. Okay, I have like 6 hours of processing, but if I do it in 8, who cares? Because I can pick up where I am, take the cheapest resources you can. Spot VM is perfect.
Exactly. Especially for data manipulation with batch or stuff like that. But your job and your program need to be fault tolerant. You can stop when the machine is shutting down by GCP. Yeah?
So is it possible when the spot is stopped to have an automatic function to
Yeah.
restart it?
Because when you are doing any action inside GCP, inside your project, creating an instance, putting an EIM role on these resources, on this user, everything is logged. Everything.
It's events. You call it events or
Uh,
Logging, monitoring.
logging?
it's in
Yes.
the log explorer
Mm-hmm.
inside the web console.
That's a good
But we have a bunch of type of logs, system logs, event log, audit log, related to maybe in another session we're going to talk about that. But when you are creating, shutting down, restarting an instance, there is a dedicated entry inside log explorer. And with Cloud Function, for example, you can, based on the log, you can create a thing to just send the log inside a topic, a pub/sub messages, for example, and your Cloud Function is waked and is triggered when this event is triggered, and you can create your Python code, not whatever the language that you are using, to just okay, my machine is shut down, I'm going to restart it right now. You can think about
These logs are triggered by default.
yeah, for sure.
Do we pay for them? Or?
The log? No, you don't pay for the, I can't remember I think it's 60 gigs of logs. Within each project, you have 2 buckets who is created by GCP when your log, where your log are stored. Okay? And these buckets are free of charges. yes, you have a bunch of information, but all the information.
I don't know how
Data
back.
access, for example, for this is a critical stuff. Oh, who is this guy? I need to know my PDF inside this bucket. What is the person who just read this object, especially for data access? But yes, everything is logged inside GCP.
So if I run any service, there is going to be log. So you can scan your logs here and say, okay, my Spot engine is now shut down. Okay, run it again, and then it's going to restart it, right? So this is how. So that is one of the questions for the certification. So which instance you will use in this particular scenario? We are going to have some questions on related to that. We are going to practice those ones as well. Just really quickly, so they are not going to test you which one, like E2 micro, none like this. You don't have to remember all these things, like how much vCPU is there or high CPU. The only thing is you need to understand it, like how I learn this. I learn by doing it. If you are not showing me the console, I'm gonna be lost. So if just showing me or talking, there is somewhere console, you log in, you do this and that. No, I need to play with it, then I know, right? So that's how I learn. So I deployed so many projects before doing all the certification. Actually, before each certification I had a different project to work on. Data engineer was a little bit tricky, but before that I had the smaller ones. Okay, so so these are how the how many or which one you want to use from this one. Now let's go to OS now. So they already give you this. This is the default one, Debian. So you need to change. So add a triage again. Let's go back to this example. As a triage, you need to know. Hey, you know what? Company is gonna give you a template, and we are gonna be configuring an instance. Then you have to choose from this one. So basically, if I am very new, I won't even know how to change this operating system. Even I can change or not, right? So that is, we should be trained to in associate certification. We should know all these things. Data protection, like backup plans or no, do you want, it's going to cost or no backups. Networking, we talked about already. So if you have a website, so HTTP or HTTPS, or I can just remove HTTP. Yeah, these are all that we need to consider. And what about the load balancer checks all? So and then security. So basically, when you go through all these options, you just create, and then there's going to be an instance. So Spot instance is going to create, and that is one of the service. Yes, please.
Can you go back just a little bit on the OS and storage?
OS and storage, yes.
So you can actually deploy a container alongside with the VM?
Yeah, yes, but this is not active, I believe. Let's try this one. I think it says there. Yeah, the options is deploy container VMs is deprecated. So because they want you to use Cloud Run,
Yeah.
they don't want you to have this.
They have a bunch of services to just deploy your container, but before they have those kind of services, it was really useful to create a machine and deploy some Docker inside. So basically, you can always do that, and just like installing Docker engine inside the Compute Engine, and you are telling just the URL of your Docker image and the version of your Docker image. You can put some dedicated command arguments on environment variables, and when the machine is launched, your Docker is started. But boom. You don't
Good.
need to do that anymore. But
Yeah.
if you have a website or stuff like that.
Yes. So let's do. Let's take a break now, right? And then we'll come back. Thank you so much. 15 minutes. Thank you.
There's some food right there, so feel free to go and it's not pizza.
It's not pizza.